Today's video, it's all about continuing on from where I left off in the last video. So what happened in that video, it took a long time to actually dismantle the variable frequency drive and test some of the components. So in this video I will be testing that IGBT module, that one there and that one there, and we'll have a look at it. So what happens with these modules, they're called an IGBT. So what does that mean? It's insulated gate bipolar transistor. So what we've got on here, I've looked up the numbers for these two transistors. This is the DC braking module. These two transistors are bipolar transistors, so they're different from these transistors. So I've got two for here, and we've got two for each side here. You go through, there's 12 transistors. So that's switching three phase, and this one here is switching only two sides of these three sets of transistors here. Here is a close-up of the DC braking module, and the right hand side is the part number and Infineon is the manufacturer. And I highly recommend you to go and have a look on the website and check out that number, and you'll see a lot of interesting information and how to connect this transistor up. This is a closer look at the DC braking module, and just there is the first gate, G1, and E1 is connected to the emitter. There's G2 and E2, and this one here, this one is a gate but it's not identified. You have to find that out yourself. I've had a quick look at the printed circuit board here, and what I've found is just here we've got G1, G2 and G3, but also there's E1, E2 and E3. With the gate over here, these gates actually switch the transistor on and off, and with the E1, E2 and E3, they are connected to these large terminals here which conduct a lot of power through the transistor. This is a 6-pack transistor. There are 6 transistors in here. So what I'm concerned with, only this block here and also one transistor here. So there's 2 transistors in there. So what I'll be doing, I'll be testing that half of it first. So we go across to here, we've got E1. Now it could be any one of them there. It's definitely not that one. Aha. So that is where I've got to connect the negative from a battery if I'm going to test this transistor. We'll go across to here. No, it's not that one, or that one there. Yep. So this one here is the connector. So what we'll test also, we'll put it on the gate. Now it's insulated, so there should be a lot of resistance in there. Across to there. Then to here. To there. So that gate is okay. So I've identified that half. So what I need to do now is, this is the second half, this is the other transistor. So we've got G2 and E2. So the first thing we'll do with the E2, we'll go across to there. No, it's not that one. No, it's not that one either. So we'll move across to here. Yeah, it's definitely that one. Go across to here. So we've got that one identified. So what are we up to? We still need to identify these 2 terminals. So we've got G2 and E2. They're not it. So I'll go across to here. We've got 3 more terminals here. So I'll go across to here. Oh, lucky first. So we've got that one identified. So I'll go across to here. and that's the second one identified. So that means that one there in the centre is the gate. So I go across to here, but then we'll go across to here. Yeah, there's something wrong there with that gate. It shouldn't do that. There is another thing we've got to check. Between here and here is a diode, and between here and here is another diode. So what I need to do, I've got it in diode function on the multimeter, and go across to here, swap the leads over, and we've got 0.33 volts. So that diode's working. You go across to here, this one is the opposite way, 0.33. So that diode is important because if you connect it the wrong way, it'll bypass the gate and the transistor will be on all the time. So it's important you know about the diode in these transistors. I've tested these 4 transistors off camera. It's a bit of a laborious process, so it shortens the video. But anyway, you've got G1, G2 and G3, which means this one here and this one here and this one here, they're working okay. This transistor and this one, yeah, I suspect they are faulty. There's something wrong with them. So the next step is to connect the battery to these transistors, confirm what the multimeter shows to see if the transistor will work or it won't work. Now we've got the battery connected. So you remember what I said about E1, that is connected to there. So we've got the negative, we'll connect it up to here, and we'll connect the other side of the light globe to here, and no light lights up, which is good. That part of the transistor is working. So we'll test the diode now. We'll swap these leads around like so. And look at that, the light comes on. So remember I said there's a diode in between there. So if you use that, you connect the wrong way, you're bypassing the gate and the transistor will switch on. So I'll bring it back to the original way we had it, way it's supposed to be. Now we'll connect up the gate and we'll see what happens there. Look at that. That transistor is working perfectly. See, it switches it on and off. This is the second transistor, same way as this one here. We connect it up here and here, no light lights up. So we go across to here and we'll see the light lights up. That is because the diode is bypassing the gate. So what we'll do, bring it back around to where it's supposed to go. Now, this is what we switch the transistor on, positive, and we go across to here, and look at that, switches on and off, it's okay. So we go across to the next one, same thing again, it's not on. Then we go across to here, the diode's working, so I go across to here, and then we go across to the gate, it's gate number 3, and there it switches on and off. So those 3 are okay, but these transistors here are suspect. So now we're doing these 3 sets of transistors, and we'll see what the multimeter has said is faulty at the gate. So remember, this one here is connected to here, so I'll put it across to here. The light shall not go on. No, it doesn't. So I bring it across to here and the light comes on. So the diode works, but we're not sure whether that gate works or not. So I bring it back to the original position. Now this is a scary bit. When I checked that, it looked like it was a short circuit. So I'm a bit wary of touching that. Oh yeah, see that? The light doesn't come on and you see all those sparks coming. So that means all the other ones on that side are all no good. So this is the second transistor where the multimeter showed that the gate was faulty. So we'll just do a quick arc across there. Yep, that is shorting out. It's no good. So I've connected up the third transistor and the multimeter showed that it was faulty, so we'll go and touch it again. Ooh, look at that sparking again. Yep, that's faulty as well. The multimeter does not lie. The battery test is showing up the problems on these ones here, these transistors here. So there is a slight possibility that this circuit board is interfering with the gates. So what I might do later on in the video, I'll unsolder all this and try it all out again. But lucky for me, this module is the same as the other two modules. Only thing is, they're double the amps, but all the connections are all in the same way. So I'll do the same thing. I'll use a multimeter and then I'll use the light globe and a battery, and we'll see if the same thing happens with the other two modules. On the right hand side you will see the part number for the twin module pack that I'll be testing, and I highly recommend that you go on to the website and have a look at their information. It's very useful and it shows you how to connect these things up. This is the other two modules. I've got the multimeter ready, and there's the other module. So what I'll do, get the multimeter and we'll do a test on the gate. So that's the gate there. That's okay. Go across to this side. That's okay there. So what we'll do, this is the other side on the other module where it wasn't working. Now the meter settled down. Yep, that's working okay. And that's okay. So now I can connect the lights up, the battery, and try it out. So I've got the battery connected up for this transistor. So we've got the light just there. It's a bit hard to get it in there. Yep, that one works. So we reverse the connections over. So we've got this one here, and this is the one that was the problem on the other module. Now if I touch that, it shouldn't spark. It'll switch the light on and off. Look at that. Nothing wrong with that side. So that module, there is a problem with it, but I'll still unsolder the circuit board and I'll try a simple circuit and see if I can get the transistor switching on and off. The next step in testing this IGBT module is I've unsoldered the board, but we'll just give it a quick test and we'll see it still goes on and off like that. So we'll take it off. Now we'll switch it on. Now see, there's an important difference. It actually stays on. So there is something in that board that's switching it on and off, and we'll go into that a bit later on in the video. So I'll connect it over to negative. So watch what happens. Switches it off. So what happens with this, if I go and put my finger on here and on here, it switches it on. And then when I go to negative, it switches it off. Now here comes the interesting part. I've swapped over the connections here. Remember these three here, these gates I've marked with the texter. They show the ones that were arcing out and shorting out. So if we go and touch one, oh look at that, it switches on. So there's nothing wrong with that gate. There was something in that circuit board that was causing it. So we go across to here, switches off. And it'll be the same with all the other ones there. So now we know that that circuit board is causing some problem in there, and we'll have a look at it. Here is the offending circuit board, and I had a close look at it and I found out why these were shorting out. This is the gate, this is another gate, and there's another gate. Now close to here is a tract. It's very hard to see. I'll do a close-up for you. And here, they're shorted out the ground. So remember, when I put my finger on the negative side of the battery to the gate, it switched it off. So what they've done is shorted out all these three gates, and these three gates here are the only ones that are working. So with a DC braking module, I assume that what all they're doing is switching them on, these three transistors this side here in parallel, and all the other ones here they're not using at all. This is a closer look at the PCB. The lower hole is where the gate pin comes through and is soldered through, and the upper hole is where it goes to the emitter, so it's ground or negative, so it always keeps it switched off. And you can just see between the two of them, you can see a track that's very close to each other. So this is why those were shorting until I took the circuit board off. But the other reason why they're switching it off too is because the capacitors connected to positive and negative, the negative side on the transistor, but also the positive side. So if they accidentally ever switched on, it'd be one massive fireworks show. So this is why they short out the other gates, and that can never happen. Here is a very simple circuit that I've connected up to the DC braking module, and now I've got it to oscillate. So it's an inverter. So we'll start with the battery. We've got the positive terminal in the battery. It goes over to here, and this is the center tap of the transformer. So what we've got, this part here is bridged so we can connect the two transistors together, and here we go through here, and that will connect the negative to the transistor. So what happens is they're the two gates, and we've got two outputs here which are separate, and they go over to here and here in the transformer. So you've got roughly 12 volts going in, and the transformers at 240 volts, and will run this 40 watt light globe. So we'll switch it on, and there it's running. Works really well. So what I can do is, I've tested those two, I can test that one and use either that one there and then those two last to make sure that it all works, but I'll do that off camera. But it all works. It's a very simple circuit. So why did it get thrown out, this variable frequency drive? Well, I've got no idea. All the big components work, but they're still the control boards, but I'm not really that interested in them because they are only low quality components. These components here are the really good quality components that I'm after.